Assalamu alaikum. How are you, students? Hope you all are safe and sound in this pandemic situation. I am also fine. So, dear students of Standard 11, welcome back to my physics class. Dear students, today I will start a new chapter, that is chapter 9, and it is named as Atomic Model and Nuclear Physics. Some of you told me to start this chapter at first before starting other chapters, earlier chapters, because this chapter is chemistry related and it will be easier for you to understand. So today I will discuss some topics. Those are I will explain atomic model, the atomic model given by Thomson and Rutherford model. I will discuss these two models today. So let's start the class. At first, development of the concept of atomic structure. During the last century, it was clear that everything of the universe is composed of atoms. It was also established that there are electrons and protons in every atom. The atomic model is based on how electrons and protons are arranged in the atom. So in this chapter, we shall discuss about different atomic models, radioactivity, nuclear reaction. The word atom is a Greek word. The Greek word atomos means not able to be divided or indivisible. And the name atom is given by the Greek scientist Democritus. So let's know what did Democritus propose about the atom. Atoms are small hard particles made of a single material that's formed into different shapes and sizes. They are always moving. They form different materials by joining together. So what is an atom? An atom is the smallest particle that an element can be divided and still be that element. Here piece of iron, carbon, and here the atomic structure of the carbon atom. Now let's know about the atomic model that is given by Thomson and Rutherford. In 1899, J.J. Thomson proposed Plum pudding model. In this model, he said that electrons are embedded within the continuously distributed positive charge inside the atom, just like the plums are distributed in the pudding. Look, I think all of you like pudding too much. I also like pudding. So you can observe in the pudding the kishmish, or that means plums, are randomly distributed. So Thomson proposed one atomic model. He thought the electrons and the negative charge, that means electrons, are the plums, and the positive charge, that means the pudding is to be considered as the positive charge, and in the positive charge the negative charges electrons are distributed randomly. In our country, this model can be compared with watermelon. In the summer season, you eat watermelon. And why it is watermelon model? Because the juicy portion of the watermelon is the positive charge, in which the seeds are randomly distributed or act as the electrons inside an atom. The whole positive charge of the atom is equal to the negative charge. So then the atom will be electrically neutral. And Thomson said the electrons are confined within the spherical atom of radius 1 angstrom. That means 10 to the power minus 10 meter. Later on, Thomson's model was proved wrong Then Ernest Rutherford gave Rutherford's model. In 1909, Ernest Rutherford designed an experiment to test the plum pudding model. In the experiment, positively charged alpha particles were fired at the gold foil. Most alpha particles went straight through the foil, but a few were scattered in different directions. So let's see that experiment. So here, alpha particle is the radioactive, from the radioactive substance, alpha particle is scattered. So here some radioactive substance radiating alpha particles, and this is gold foil. The thickness of the gold foil was taken in this experiment was 6 into 10 to the power minus 7 meter. Dear student, you must remember this thickness, because in the MCQ frequently it comes. What is the thickness of gold foil in the alpha particle experiment? It may come. On the other hand, the gold plates, there was on the other side of the gold plates, there is the movable zinc sulfide screen. When an alpha particle is incident on the screen, fluorescence was observed. That means it is light sensitive screen. This screen is light sensitive. Okay. So in this experiment, it was noticed that 99% of the alpha particle go straight, penetrating the gold foil, and some of the alpha particles were scattered, making an angle. Okay, some of the alpha particles were scattered, making an angle, as if they are going straight, getting open space. Okay, so few, that means about 1 out of 20,000, few of them went making an angle more than 90 degree, as if they are obstructed by any heavy nucleus. Look here in this animation. Look, most of the alpha particle go straight, but very few alpha particles are scattered back, making an angle. That means they collided with heavy mass that is concentrated at the center of the atom. So most of the space of an atom is empty, since the mass of the electron is negligible in comparison to alpha particle. So electrons may exist in the empty space, but they cannot change the path of the alpha particle. That's why most of the alpha particle go straight through the gold foil. Since a few number of alpha particles are returned back, so it can be said that the alpha particles collide with some massive substance heavier than the alpha particles, or repulsed by them. So that is, the total mass of the atom is concentrated or centralized within a small space, and that is nucleus. That small space is nucleus, where the total mass of the atom is confined. Since alpha particles are positively charged and they are repulsed by the center of the atom, so it is possible that the center of the atom is also positively charged. Okay, because alpha particle is repulsed by the center, and it is conceived that center of the atom is also positively charged. He named this massive and positively charged center of the atom is nucleus. The volume of the nucleus comparison to the total volume of the atom is very small. The diameter of the hydrogen atom is 10 to the power minus 10 meter, where the diameter of the nucleus is 10 to the power minus 15 to 10 to the power minus 14 meter. That is, the atom is larger than the nucleus by 10,000 times to 1 lakh times. So this is Rutherford's alpha particle scattering experiment, and from this experiment he proposed the atomic model, and that is named as solar model, that is compared to the solar model. So look, let's summarize the Plum pudding model given by Thomson and Rutherford nuclear model. So look, according to Plum pudding model, electrons are suspended in a background of uniform positive charge, not concentrated enough to repel the alpha particles. So all alpha particles are virtually unaffected and passes straight through because the charge density is not great enough to affect their trajectory very much. So look, here alpha particle goes straight. And according to Rutherford model, positive charge concentrated in a very tiny dense nucleus, dense enough positive charge to repel the alpha particles that get close enough to it. So alpha particle heads straight for the center of the concentrated charge and gets repelled enough to back scatter. Look, most of the alpha particles go straight, but few scattered back, making an angle. Alpha particle passes close enough to be deflected. Those alpha particles which are very close to the nucleus, those are deflected. Okay. But here, look, there is empty space, so it goes straight. But at the center, where the nucleus, that means where the mass of the whole atom is concentrated and which is positively charged, so those are very close to the nucleus, those will be deflected. That means the alpha particle will be repulsed. So this is all about alpha particle scattering experiment. Now there are some questions can arise in your mind, and I want to answer those questions. Cause of using gold in the Rutherford's experiment. For the metal foil, they tested a variety of metals, but they preferred gold because they could make the foil very thin, as gold is very malleable. As a source of alpha particles, Rutherford's substance of choice was radon, a substance several million times more radioactive than uranium. Now, another question. What is the importance of Rutherford's scattering experiment? Rutherford's experiment utilized positively charged alpha particles, that is helium, with alpha A plus. It will be alpha actually, which were deflected by the dense inner mass nucleus. The conclusion that could be formed from this result was that atom had an inner core which contained most of the mass of an atom and was positively charged. Conclusion of Rutherford's scattering experiment. Most of the space inside the atom is empty because most of the alpha particles passed through the gold foil without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. So now we will discuss Rutherford's atomic model. So from Rutherford's alpha particle scattering experiment, it was proved that Plum pudding model is wrong. So then Rutherford gave one atomic model which is compared to the solar model. The model described the atom as a tiny, dense, positively charged core called a nucleus, in which nearly all the mass is concentrated, around which the light negative constituents called electrons circulate at some distance, much like planets revolving around the sun. and the atom is electrically neutral. Therefore, the number of negatively charged electrons around the nucleus, here the nucleus, is equal to the number of positively charged in the nucleus. That's why an atom is electrically neutral. So look, this is great scientist Rutherford, and he gave this atomic model which is compared to the solar model, because you know in the solar system sun is at the center and other planets are revolving around the sun. So like the solar model, here also in the center of the atom there is nucleus, and in the outer orbit the electrons are revolving around the nucleus. The electrons revolve around the nucleus as the planets revolve around the sun in the solar system. So two types of force are acting on the nucleus. The electrostatic attractive force between the nucleus and the electrons acts as the centripetal force. Now, limitation of Rutherford model. Limitations of Rutherford's model. There are some limitations in the Rutherford model, and that is, an electron accelerating around the nucleus would continuously emit electromagnetic radiation and lose energy. Look, when electron moving around the nucleus continuously, then they will radiate electromagnetic radiation, and then what will happen? They will lose energy. Therefore, it would eventually fall into the nucleus and the atom would collapse. That means if you want to write something on the board, then before finishing your writing, the ink will be finished. Then, however, this is not consistent with real world observations. Atoms are stable. Look here, the electrons should fall on the nucleus if it revolves around the nucleus continuously, and if it radiates energy and loses energy. Then that is shown in this figure. And in the Rutherford model, no information is supplied about the shape of the orbit of the revolving electrons. So later on, again, Neil Bohr gave one atomic model, that is Bohr atomic model, and that is still now that is the perfect atomic model. So in the next class, I will explain that. Today up to this, dear student, all the world is full of suffering. It is also full of overcoming. You should remember this in your mind. So goodbye everybody.